the silence of deep space, imagine a web of secret messages crackling across the cosmic void, messages that you will never hear. Imagine that above us, there's a presence watching and waiting, not because they are benevolent guardians, but because they are terrified of making a sound. What if the night sky is not empty at all, but full of eyes hiding behind stars, listening for anyone foolish enough to speak? We look up at the glittering expanse and think that nothing is looking back. Yet the real reason we have not found aliens might have nothing to do with our cleverness and everything to do with the rules of a game we did not know we were playing. Could our galaxy be a forest of silent hunters, each one hiding its campfire in dread of an unseen predator? Could our own transmissions be a beacon that makes us a target? Or perhaps, is this very idea itself a myth that makes us feel better about the vast loneliness we do not want to face? Imagine a scenario in which an advanced civilization points its telescopes toward our world and decides not to answer, not because they fear us, but because they cannot. Maybe they reached a point where science itself slowed down, where the next step in technology became a mountain too steep to climb. That would mean there are ghostly civilizations out there, trapped by the same barriers of physics and biology that we face. It would mean that the cosmos is not a playground filled with city lights, but a graveyard of sparks that flared and faded. If that thought sends a chill down your spine, ask yourself, would you rather live in a universe populated by unseen civilizations that hide from one another, or one in which the spark of consciousness is so rare that we are alone? Let me know what you think, because this question shapes how we see our place in the cosmos. As you settle into the darkness, picture our planet as a single speck among hundreds of billions of stars in our galaxy, itself one island among trillions in the observable universe. The famous contradiction known as the Fermi Paradox asks why, if life and intelligence are not unique to Earth, we see no signs of them. We have been listening for decades, scanning the skies for radio beacons, watching for laser flashes, and looking for giant engineering projects. Yet the data are quiet. Is this because every civilization hides, as some storytellers claim, or is it because of something more mundane? There is a popular notion called the dark forest hypothesis. This idea suggests that the universe is like a dark woodland at night, full of hungry hunters. Each civilization, no matter how different, supposedly decides that announcing its presence is suicidal. It is a story that resonates because it taps into our primal fear of being hunted. In such a scenario, silence is the only strategy that ensures survival. If an alien species hears a radio broadcast, it might interpret it as the call of prey and strike before the other can strike first. This hypothesis has been dramatized in novels and games, and it is deeply unsettling to imagine that the cosmos is a place where trust is fatal. Yet when scientists step back from the melodrama, they point out that the dark forest depends on a universal psychology. It assumes that every species, regardless of biology or culture, will independently reach the same bleak conclusion that silence is safety. Real social sciences show us that even on our planet, human societies make wildly different decisions about trust, cooperation, and risk. Anthropologists and historians study why some groups are isolationist while others explore and trade. Astronomers note that it is unlikely all alien societies would think in exactly the same way. Some might be cautious, others curious, some expansionist and some indifferent. For the dark forest to be universally true, the cosmos would need to enforce a single, fear-driven logic on all minds. That is a bold claim, and one that is difficult to support. So, is it a conspiracy among aliens to hide, or is it simply a story humans tell to make sense of silence? The more plausible explanation is that some civilizations might be quiet, but it would only take one less cautious culture to broadcast loud and clear for us to pick it up. There is another possibility that is less sinister but equally sobering. Maybe advanced life is extremely rare. Scientists call this the rare Earth hypothesis. When we imagine the probability of life in the galaxy, we often think of how many Earth-sized planets orbit in the habitable zones of their stars. Modern surveys suggest that there could be tens of billions of such worlds around sun-like stars. But the rare Earth perspective goes further and lists the special conditions that may have been crucial for complex life here. Our planet has plate tectonics that recycle carbon and stabilize climate over geological timescales. We have a magnetic field that deflects harmful solar radiation. A large moon stabilizes the axial tilt, preventing chaotic seasons. There is a giant planet like Jupiter in the outer system that deflects comets, The star we orbit is relatively calm and long-lived. Our galaxy is not too densely packed and sits at a distance from the galactic center. Each of these features reduces catastrophic risks. If even a few of them are necessary, Earth might be a cosmic lottery ticket drawn against astronomical odds. Under this view, microbial life might be common, but advanced civilizations might be so infrequent that we would expect to find none in our neighborhood. The absence of contact would not be because aliens are hiding, but because they never arose in the first place. At this point, your mind might race with questions. If life is rare, does that make our existence precious or terrifying? Does rarity impose an obligation on us to preserve life? Or does it give us license to do whatever we wish because there is no one else to witness it? Think about the choices you would make if you learned that humanity is the universe's only storyteller. Would you live differently? Share your thoughts below, because contemplating our cosmic solitude is as much a moral exercise as a scientific one. Even if life itself is not rare, there might be a series of cosmic hurdles that few can clear. This is the idea behind the Great Filter. Imagine the development of a technological civilization as a sequence of necessary steps. Life emerges from chemistry, single cells evolve into complex cells, multicellular organisms appear, intelligence develops, tool use becomes advanced, industrial society arises, and eventually interstellar travel or communication is achieved. The Great Filter hypothesis says that at least one of these steps is extraordinarily improbable. Most lines of evolution fail to cross it. If the filter is behind us, then we have already passed the hardest obstacle, and other civilizations likely failed before reaching our level. If the filter is ahead of us, then we face an upcoming barrier that nearly all intelligent species fail to overcome. It could be self-inflicted, like war or environmental collapse. It could be technological, like the difficulty of mastering controlled fusion or artificial intelligence without wiping ourselves out. Or it could be external, like periodic asteroid impacts or nearby supernovae that reset progress. The Great Filter is not a conspiracy. It is a statistical reality in which survival is the exception. If our search for aliens yields nothing, it might be because the universe is littered with the fossils of civilizations that could not cross the chasm. Another less discussed explanation is that there is a universal limit to technological development. This idea suggests that there are physical and economic barriers that prevent any civilization from reaching the level of energy and control needed to colonize the galaxy. On Earth, we see hints of this. The major revolutions in physics, like relativity and quantum mechanics, happened over a century ago. Building particle colliders now costs orders of magnitude more energy and resources than the ones built by our grandparents. Projects like the International Space Station, giant fusion experiments, and next-generation accelerators face astronomical price tags. Meanwhile, the laws of physics impose absolute speed limits. You cannot accelerate a massive object beyond the speed of light. The energy required to push even a modest spaceship to a significant fraction of light speed grows exponentially. To travel to another star within a human lifetime would require so much fuel that it strains even theoretical designs. It is plausible that after reaching a certain threshold, each increment in technology demands exponentially more resources, effectively creating an uncrossable gap. If that is true, then no species, no matter how ingenious, will ever build fleets that span a galaxy. They will remain confined to their stellar neighborhoods. In such a universe, each island of civilization might be restricted by the same bottleneck. That does not mean aliens are hiding. It means they are stranded by the same cosmic physics that strand us. While contemplating cosmic horizons, we must also acknowledge that our attempts at detection have only scratched the surface. Radio telescopes have scanned the skies for over half a century, but their coverage is minuscule compared to the scale of the Milky Way. A widely cited estimate suggests that we have examined roughly 1/1,000,000th of the galaxy for radio signals. That is like dipping a cup into the ocean and declaring there are no fish. Our focus has been largely on stars within a few hundred light years, a tiny bubble in a galaxy about 100,000 light years across, with hundreds of billions of stars. Moreover, we have not been listening continuously. Observations are often limited in time and frequency. A powerful beacon pointed directly at us could flash when our antenna is turned the other way. In addition, the signals we seek must stand out against cosmic noise. A broadcast loses strength with distance, obeying the inverse square law. Our own early television and radio transmissions have only traveled about 100 light years so far. Beyond that, They are so attenuated and distorted by interstellar plasma that they become indistinguishable from the background hum. If another world did the same, we would not hear them unless they invested enormous energy into directed beams. Communication across interstellar distances requires both parties to transmit and listen with intention over centuries. Otherwise, the cosmos remains quiet simply because the calls are too faint to be heard. To complicate matters further, recent research shows that even ideal narrow-band signals might be blurred before they leave their home stars. Plasma near a star can scatter radio waves, broadening what we would perceive as a perfect spike into a wider shape. Traditional search algorithms look for extremely narrow features because they stand out against noise. If the signals are slightly broadened, our filters may discard them as noise. The effect is more pronounced around red dwarf stars, which make up a large fraction of the galaxy. This means that many potential transmissions could have been missed simply because we did not look for the right shape. When you realize that the cosmos is full of plasma and turbulent magnetic fields, it becomes clear that our search strategy might need to evolve. The unknown in the equation may not be alien behavior, but the subtle physics of space itself. Another seductive narrative in science fiction is that aliens are using technology beyond our understanding. They might communicate with neutrino beams, gravitational waves, or quantum entanglement. They might build megastructures around stars or even switch to digital forms that live in virtual realities and thus lose interest in the physical universe. There is no evidence for such technologies, but it is worth considering that the methods we expect may not be the methods that exist. Our instruments are tuned to what we know, and our imagination is limited by our experience. The absence of evidence is not evidence of absence. However, it is also not evidence of an interstellar conspiracy. It simply reminds us of the humbling fact that we might not yet be listening on the right channels. Many people are drawn to the idea of a hidden galactic federation or a cosmic quarantine. It plays into our love of stories about secret councils and unseen watchers. We imagine that aliens are observing us, waiting until we cross a moral or technological threshold before revealing themselves. This concept, sometimes called the zoo hypothesis, has been popularized in countless shows. It is a comforting thought. We are not alone. We are simply not ready. But like all comforting thoughts, it should be scrutinized. If there were a federation capable of monitoring millions of worlds, it would require technology far beyond what we know. Why would they care about a species on a small rock around an average star? And how could they maintain secrecy for billions of years? We project our own institutions onto the cosmos because we crave structure. In reality, the universe is indifferent. It does not conspire to keep us ignorant. It simply is vast and obeys the laws of physics. The dark forest, the rare earth, the great filter, the technological ceiling, the limitations of our search, and the possibilities we have not yet imagined all offer pieces of the puzzle. There may not be a single reason why we have not found evidence of other civilizations. It could be a combination of rarity, distance, physics, sociology, and time. Consider that our species has been sending radio signals for less than a century. If the average lifespan of a technological civilization is a few thousand years, the chances of two such civilizations overlapping in time and pointing their transmitters at each other is small. Multiply that by the vastness of space and the finite speed of light, and you begin to see why the cosmos is quiet. We might be listening during a cosmic lull between the rise and fall of others. One more angle is simple perspective. Humanity tends to think we are typical, but we may be an outlier. We may have arisen earlier than most, or later, or in a part of the galaxy less favorable for contact. The cosmos is nearly 14 billion years old. Our planet formed 4.5 billion years ago. Suppose technological civilizations are common, but appear mostly in the future. Then we are early, and of course we see no one. Or suppose they mostly arose a billion years ago and have since faded. Then again, we would be alone. Time is a dimension as important as space. When we look at the stars, we are looking back in time. The light reaching us now left its source millions of years ago. So even if a civilization exists, its light we see might be from a time before it was born, or long after it died. At this juncture, reflect on another question. If you knew that intelligent life exists out there, but is unreachable due to the limits of physics, would that knowledge comfort or frustrate you? Would simply knowing of their existence change the way you live your life, Or would the impossibility of contact make it feel like a fairy tale? Share your thoughts, because this is a dilemma at the heart of our search. Is the journey toward discovery worth pursuing if the destination is unreachable? There is also a psychological aspect to our expectations. We often equate intelligence with expansion and colonization because that is what humans have done. But intelligence might manifest differently elsewhere. Perhaps advanced beings turn inward, exploring consciousness rather than space. Maybe they master energy at the quantum level, living in compact systems with no need for expansion. They might exist in forms we cannot recognize. Intelligence does not necessarily lead to starships. The assumption that aliens would leave obvious traces may be rooted in our bias. This bias fuels imaginative conspiracies about hiding aliens, but the truth may be that they do not hide. They simply do not care to be seen. In discussing hidden civilizations, we cannot ignore the possibility that we are looking for the wrong signs entirely. The search for technosignatures now includes investigating chemical imbalances in exoplanet atmospheres, industrial pollutants, or unusual heat signatures from megastructures. Future telescopes may detect these signs. However, those techniques are just beginning. We have cataloged a few dozen exoplanet atmospheres, and we are decades away from detecting subtle industrial signals. Even if there were a planet with chlorofluorocarbons or artificial illumination on its dark side, our instruments today would not detect it. The search for life is still in its infancy. To declare there are no aliens because we have not yet found any is to declare there are no coins in the ocean because we have sifted through a single bucket of sand. What about the possibility that signals are hidden deliberately? Could a civilization cloak its emissions? In theory, yes. They might use encryption, or beam their messages only to specific targets. They might transmit at wavelengths we do not monitor. But again, the question is, would every civilization do this? The dark forest theory says yes, but reality suggests diversity. Some might hide, others might shout, and many might not communicate at all. Even on Earth, some cultures share freely, while others keep secrets. To believe that all alien minds converge on hiding requires a uniformity that defies the diversity we see in nature. Our search for extraterrestrial intelligence is an extraordinary scientific endeavor, but it is also a mirror. It reflects our fears, our hopes, and our assumptions. We project onto the stars what we know about ourselves. The myth that aliens are hiding may reveal our own anxieties about vulnerability and aggression. The idea that there is a conspiracy among galaxies to keep us ignorant might echo our distrust of authority. But the cosmos is not a stage for human drama. It is a 13-billion-year-old arena governed by gravity, quantum fields, and expansion. The reasons we have not found aliens are likely natural, not nefarious. Still, the myth endures, and perhaps that is because it is simpler than the truth. Stories about secret federations or hunting grounds are easier to tell than explanations involving astrophysics, evolutionary biology, and probabilities. In a world saturated with fiction, the line between speculation and evidence blurs. That is why it is important to remind ourselves that the absence of contact is not evidence of a cosmic cover-up, but a puzzle to be solved with patience and rigor. As we bring this journey to a close, allow yourself to feel the weight of the question: are we alone? It is a haunting thought that has been with humanity since we first looked up. Some days, the silence feels like a betrayal. Other days, it feels like a gift, giving us the entire universe as a playground. The real reason we have not found aliens may turn out to be that there are none nearby, or that we have not looked long enough, or that physics keeps us apart. It might be a combination of all these factors. Aliens might be hiding, but if they are hiding behind the laws of nature, rather than behind a curtain of deceit. Before you drift off to sleep, imagine again that web of secret messages. Only this time, imagine those messages are the cosmic background radiation, the whispers of creation itself. They tell a story of a universe that began in a hot, dense state and has been expanding ever since. They carry no encoded greetings, no invitations, only the faint afterglow of a primordial fireball. Yet from that fireball emerged galaxies, stars, planets, and you. Perhaps the absence of alien voices is not a cause for despair, but a call to treasure our uniqueness. Perhaps we are the ones meant to light up the dark forest, not with fear, but with curiosity and care. Let that thought cradle you as the night deepens. Good night, and remember, the universe remains vast and mysterious, and our search is just beginning. Imagine how vast the cosmic stage truly is. Our Milky Way is a spiral of hundreds of billions of stars, and beyond it lie billions of other galaxies stretching across the observable universe. Each of those galaxies contains its own swarms of stars, many with planets. Cosmologists estimate that the observable universe is almost 93 billion light-years in diameter, yet this is only the part we can see. The universe might extend much further, perhaps infinitely. Against this immensity, our search for neighbors has been like searching a single grain of sand on a beach the size of Earth. The cosmic ocean is deep and cold, and our probes and telescopes have barely dipped below the surface. We often hear numbers thrown around. Tens of billions of Earth-sized planets in habitable zones, thousands of confirmed exoplanets discovered by missions like Kepler and TESS. These discoveries fuel hopes that life may be common. But the habitable zone is just the region where liquid water could exist on a planet's surface. Many of these planets orbit red dwarf stars that are prone to violent flares that could strip atmospheres. Some may be tidally locked, with one hemisphere baked and the other frozen. Others may have compositions or atmospheres that preclude life. A habitable zone does not guarantee habitability. And even if simple life arises, there's a vast difference between a microbial mat and a civilization capable of radio astronomy. On Earth, it took billions of years for life to progress from simple cells to complex multicellular organisms. The appearance of eukaryotic cells, which contain organelles like nuclei and mitochondria, was a rare symbiotic event. Multicellularity evolved many times, but only once did it lead to animals with nervous systems and the ability to manipulate the environment. Intelligence evolved in a few lineages of mammals and birds, and only one developed technology. Each of these steps was contingent. A small difference in climate, asteroid impacts, or genetic drift could have led to a different outcome. So when we talk about billions of habitable worlds, we should remember that the chain from chemistry to radio telescopes is long and brittle. There are also catastrophic events that can halt or reset evolution. Gamma-ray bursts, the most energetic explosions in the universe, can sterilize vast regions of a galaxy. Nearby supernovae can strip away atmospheres and bathe planets in harmful radiation. Massive volcanic eruptions can trigger global glaciations. Asteroid impacts can wipe out dominant species, as happened when a space rock ended the reign of the dinosaurs. Our planet's history includes several mass extinctions. Without each extinction event, the path of evolution could have diverged drastically. The Cambrian explosion, which introduced most animal body plans, occurred after a mysterious rise in oxygen. The evolution of vertebrates, the colonization of land, and the rise of mammals were all fortunate. It is hard to believe that these sequences would replicate exactly elsewhere. Self-destruction is another potential filter. We live in an era when nuclear weapons can end human civilization in hours. Beyond war, climate change threatens to destabilize ecosystems and economies. Artificial intelligence could spin out of control if not aligned with human values. Global pandemics, whether natural or engineered, could decimate populations. Some of these threats are unique to intelligent species. The more powerful we become, the greater the consequences of our mistakes. If advanced civilizations often destroy themselves shortly after inventing planet-shaping technologies that could explain the silence, they might leave behind relics we could detect, but those relics would need to survive for millions of years. Megastructures could degrade, probes could malfunction, transmissions could cease. We have not yet touched on the difficulty of interstellar travel. The nearest star system, Alpha Centauri, is over 4 light-years away. At the speeds of current spacecraft, traveling there would take tens of thousands of years. Even at 1/10 the speed of light, a crew would need over 4 decades just to reach the nearest star. Then there is interstellar dust, which at such speeds could obliterate a ship upon impact. Shielding against cosmic rays and meteoroids adds mass and complexity. Generational ships, where multiple generations live and die during the voyage, raise ethical and psychological issues. Hibernation technology is still science fiction. Wormholes and warp drives remain speculative. Even if they are physically possible, they might require exotic matter or energies beyond reach. The challenge is not just to build the ship, but to sustain life and society over centuries in deep space. On paper, there is a theoretical solution: self-replicating probes. These hypothetical machines could travel to a new star, harvest resources to build copies of themselves, and send those copies onwards, spreading exponentially. Mathematicians point out that such a strategy could colonize a galaxy in a few million years, a blink on cosmic timescales. So where are the probes? Perhaps they are not built because of ethical considerations. A replication runaway could consume resources indiscriminately. Or perhaps the probes face the same energy limits as crewed ships. They might also be subject to failure, mutation, or conflict, leading to self-limiting growth. Even if they exist, we might not recognize them. They could be tiny, dark, and dormant. Our own transmissions are feeble compared to cosmic distances. Early radio and television broadcasts radiated in all directions, but as technology advances, we use tighter beams and fiber optic cables that leak less into space. Alien broadcasts might follow a similar trajectory. It could be that the golden age of leakage is short, and unless you catch a civilization during that window, you miss them. Additionally, any signal crossing interstellar space must contend with scattering, dispersion, and absorption. Radio waves spread out and weaken. Molecules in interstellar clouds absorb certain frequencies. Charged particles twist polarizations. By the time the signal traverses hundreds of light years, its original message may be buried in noise. Detecting it requires immense antennas, long integration times, and precise calibration. Our best instruments are impressive, but they have limits. We cannot yet detect a cell phone ringing on a planet around another star. Astronomy is also limited by cosmic horizons. The universe is roughly 13 and 8/10 billion years old. Light from beyond a certain distance has not had time to reach us. That boundary, called the observable horizon, encloses all that we can ever see. Beyond it, events are causally disconnected from us. As the universe expands, driven by dark energy, galaxies beyond a certain distance recede faster than light. They will never be visible, no matter how long we wait. This cosmic speed limit implies that even if there are civilizations out there, some may be forever out of reach. The cosmic expansion will continue accelerating, and in trillions of years, only the local group of galaxies will remain gravitationally bound. The rest will vanish beyond the horizon. Our era, when the sky is rich with galaxies, is temporary. Future astronomers will see a very different cosmos. Another subtlety is the way we search for life. Most of our efforts focus on radio signals because radio waves can travel vast distances with less absorption than light. But life might be silent in radio. Perhaps biospheres are abundant but quiet. In that case, we would need to look for biosignatures, gases like oxygen and methane in the atmospheres of distant worlds. Instruments like the James Webb Space Telescope have begun analyzing exoplanet atmospheres, but the task is challenging. It requires blocking out the glare of the star, collecting enough photons, and disentangling the spectrum. The next generation of space telescopes aims to directly image Earth-sized planets. Spectra might reveal the presence of water vapor, carbon dioxide, or chlorophyll-like pigments. But interpreting these signals is tricky. Non-biological processes can mimic life signs. A single spectrum does not reveal culture, art, or technology. We may find a planet with oxygen and still not know if there is a civilization under its clouds. Some scientists propose that advanced civilizations might leave industrial footprints, such as pollution or artificial lights. For example, chlorofluorocarbons, which are purely synthetic on Earth, could be detected in the infrared. Artificial illumination on the night side of a planet might be seen as glints. Excess heat from large energy consumption could manifest as waste infrared radiation. We are far from detecting such signals, but they represent a new avenue. They also highlight the assumptions we make, that aliens use chemicals and technologies like ours. An advanced species might avoid polluting its planet, or it might emit waste heat in wavelengths we are not monitoring. There are too many unknowns to base our confidence on a narrow set of search strategies. Furthermore, the history of science shows that radical discoveries often come from unexpected directions. Radio astronomy itself was born when an engineer studying static discovered emissions from the Milky Way. Cosmic microwave background radiation was detected by accident while troubleshooting a horn antenna. Pulsars were first thought to be little green men. Fast radio bursts were a mystery until more were found and natural explanations emerged. It would be presumptuous to think we have exhausted the ways the universe can surprise us. The truth might be stranger and more beautiful than our conspiracies. Maybe aliens are not hiding. Maybe our understanding is incomplete. Meanwhile, consider the influence of cosmic time on communication. If a civilization forms 1,000,000 years before or after ours, the chances of overlapping in time are small. There have been stars in our galaxy since long before Earth formed. If civilizations typically last a few thousand years, they may blink on and off like fireflies on a summer night. To catch one, you have to look at the right time and direction. Multiply that by the billions of stars and the finite speed of light, and you see how improbable contact is. It is like standing on a cliff overlooking an ocean and hoping to see a single ship pass between two waves. The ship might have sailed centuries ago, or will sail long after you leave. This temporal mismatch reduces the probability of contact even if the galaxy teems with life. Let us not overlook the role of chance and time in our search. The first detection of an exoplanet around a sun-like star happened in the 1990s. Before that, we had no evidence that other systems existed. Within a few decades, we learned that planets are ubiquitous. We discovered hot Jupiters, super-Earths, mini-Neptunes, and more. The pace of discovery is accelerating. It is possible that within this century, we will detect a technosignature or a clear biosignature. Or perhaps centuries will pass without a whisper. Patience is essential. The cosmos operates on scales far beyond a human lifetime. To expect immediate answers is to ignore that we are infants in this cosmic conversation. The conversation about hiding aliens often overlooks a simple truth. Secrecy is hard. On Earth, secrets leak. Whistleblowers and accidents expose hidden projects. Transmissions leak. If a galactic federation exists, it would have to orchestrate a perfect veil across millions of worlds for billions of years without a single slip. That is implausible. In science, extraordinary claims require extraordinary evidence. The claim that every alien is hiding requires more evidence than our current silence provides. Instead of imagining conspiracies, imagine cooperation. Imagine that somewhere, another civilization struggles with the same questions, wonders why it hears nothing, and tells stories of hidden neighbors. They, too, grapple with fear and hope. They invent their own dark forest, their own great filter, their own myths. Perhaps the universe is filled with lonely storytellers. If one of those stories ever crosses the void and reaches us, it will be a moment of profound connection. Until then, our duty is to keep listening, to refine our instruments, to broaden our minds, and to tell stories that inspire us to explore, rather than retreat into fear. To ground ourselves in reality, we can look at the cosmic background. The afterglow of the Big Bang is a uniform microwave radiation filling space. Its tiny fluctuations reveal the seeds of structure that grew into galaxies and voids. There is no hint of messages encoded in this hiss, no hidden patterns indicating design. The universe appears to follow natural laws. Gravity pulls matter together, forming stars and galaxies. Nuclear fusion lights the stars. Planets accrete from disks of dust. Life, as far as we know, arises from chemistry. The absence of aliens does not suggest a glitch in this cosmic software. It suggests that the code is more complex and that our debugging process has just begun. Finally, there is the human element. We are the only species on Earth that looks outward in this way, that builds instruments to probe the edge of the observable universe. Our curiosity drives us to ask questions with no easy answers. Whether we are alone or not, the act of searching enriches us. It forces us to confront our significance and our fragility. It inspires art and philosophy. It unites people across cultures in a shared quest. The silence of the stars is not a verdict. It is an invitation. It invites us to explore, to cherish our world, and to imagine with humility and wonder. And with that, we come to the end of our journey through the quiet night. You have traveled through forests of fear and fields of hope. You have considered conspiracies and confronted facts. You have pondered your own choices and peered into cosmic mysteries. If you feel a sense of awe, hold on to it. If you feel unease, let it motivate you to learn more. The real reason we have not found aliens may be a tapestry of reasons, woven from rarity, distance, time, physics, and our own limitations. There may come a day when that tapestry unravels, and a voice from the void answers ours. Until then, look up and listen. The universe is speaking, even if the language is not what you expected. And your place in this story is to keep asking questions and to keep the fire of curiosity burning.